This is Pre-Algebra Chapter 2.3, Simplifying Variable Expressions. Take a look at this written expression. It has several different parts that have specific names. Each part of the expression that is added together is called a term. 5x, 4x, and 7 are the terms of this expression. The coefficient of a term with a variable is the number part of the variable. So 5 and 4 are coefficients. Finally, a constant term, such as 7, has a number but no variable. Finally, like terms are terms that have identical variable parts. So in this expression, our like terms are 5x and 4x because they share the term x. Two or more constant terms are also considered like terms. For example, if we had another constant term, say we added plus 5, then 7 and 5 would be considered like terms. Let's go on to identifying these in another equation. In this expression, y plus 8 minus 5y minus 3. First, let's rewrite this expression as a sum. That requires us to write y plus 8 plus negative 5y plus negative 3. Next, let's identify the different parts of the expression. Note that because y equals 1y, the coefficient of y is actually 1. Okay? It's an invisible 1 here. So what are our terms? Our terms are y, 8, negative 5y, and negative 3. Our like terms come in pairs in this particular expression. 1y and negative 5y are like terms, and 8 and negative 3 are also like terms. Our coefficients are 1 and negative 5, and our constants are negative 3 and 8. Now let's learn what we've used about the distributive property to write an expression such as 7x plus 4x as a single term. We can take 7x plus 4x and use the distributive property to create a single term. We can remove the x and put 7 plus 4 in parentheses. These two things are equal, but we've gone from two terms to one term. Going one step further, we can also simplify this expression by simply adding our 7 and 4 together to get 11 and multiplying that by x. So 11x is the simplified version of 7x plus 4x. We call a variable expression simplified if it contains no grouping symbols and all the like terms are combined. So 11x qualifies. Let's try another example of simplifying together. 4n minus 7 minus n plus 9. If we choose to use the commutative property and reorder this particular expression, we can put the like terms together. So I'm going to rewrite this as 4n minus n minus 7 plus 9. And that puts all of my like terms together. Now I'm going to use the distributive property to help me move my n's here. So I'm going to pull out my n. Take 4 minus 1. Remember, in front of this n, there's a 1. Minus 7 plus 9. So that gives me, if I combine these, 3n. And let's combine negative 7 and 9. That gives us positive 2. And our simplified expression is 3n plus 2. Try these three problems on your own. Record them in your homework notebook. If you choose to add the coefficients mentally, in other words, if you choose to combine 3 and 5 mentally and simply write the answer for the number of x's that we have, that's fine. That is a perfectly acceptable mental math shortcut. Now let's move on to slightly more complex expressions. We're going to simplify some expressions that contain parentheses now. So here is our sample problem, 2 paren x minus 4 paren plus 9x plus 1. So the first thing we'll want to do is make use of the distributive property. Let's move this 2 into these two digits so that we can figure out exactly what we're working with. So we have 2x minus 8 plus 9x plus 1. Next, we'll combine like terms. 9 plus 2 gives us 11x. Negative 8 plus 1 gives us negative 7. And here is our simplified expression. Here's another expression that includes parentheses. Let's solve this one together as well. So we'll start with 3k. We'll use the distributive property to distribute 8. So we'll have minus 8k minus 16. Why is this a minus sign? Well, because 8 is negative, 2 is positive. When the signs are different, you use the negative. Okay, so don't let that trip you up in future problems. So 3k minus 8k combined gives us negative 5k minus 16. So here is our simplified expression, minus 5k minus 16. One last problem to try together. 4a minus parentheses 4a minus 3. In this case, we're going to begin with the identity property, which you'll recall means that any number multiplied by 1 equals itself. So we'll rewrite this as 4a minus 1 times 4a minus 3. See where that comes from? There's actually an invisible 1 in front of here. Okay. Now we use distributive property, and we get 4a minus 4a plus 3. Why plus? Because we have a negative sign here and a negative sign here. So when we multiply those two numbers together, we get a positive result. 4a minus 4a equals 0 plus 3. So our simplified expression is simply 3. All right, try these 3 problems on your own. Simplify these expressions with parentheses. Make sure you use all of the properties that you've learned and show your work. And here's our last idea for this lesson, which involves a word problem. It goes like this. You work out each day after school by jogging around a track and swimming laps in a pool. During your workout, you spend a total of 45 minutes jogging and swimming. You burn 14 calories per minute when you're jogging, and you burn 8 calories per minute when you're swimming. So we're going to let J be the time you spend jogging in minutes. So write an expression using the term J for the total calories you burn during your workout. Okay, so how are we going to do this? Well, we know that we have calories per minute jogging times the amount of time spent jogging plus your calories per minute swimming times the time spent swimming. This equation will give you the total number of calories burned in the workout. So let's use this sample equation to help us write an expression in terms of J that tells us the total number of calories burned during the workout. All right, so what do we know? We know that jogging burns 14 calories per minute and that swimming burns 8 calories per minute. We also know that jog time is represented by J. We also know that the total time equals 45 minutes and that jogging time plus swimming time equals 45 minutes. Therefore, if we want to write this in terms of J, then S would equal 45 minutes minus J, correct? All right, now let's write our final equation. So for jogging, we'll represent 14 times J, the calories per minute burned times the time, plus 8 times 45 minus J, the calories burned swimming times the time spent swimming. Now let's simplify. We have 14J plus 360 minus 8J. j. Oops, we need a little bit more space here. One moment. Let's finish simplifying this. So 14j minus 8j would give us 6j plus 360. Our final simplified expression is 6j plus 360. Now let's evaluate this expression. How many calories do we burn if we jog for 20 minutes? So if j equals 20. Well, first, we substitute j into the equation, or 20 for j into the equation, 6 times 20, plus 360. What's 6 times 20? It's 120 plus 360, which gives us a final calorie count of 480. 480 calories are burned. All right, good luck with the sample exercises. I'll see you tomorrow to talk more about simplifying expressions.